Hello, welcome to Tuesday's edition of Cracking the Cryptic, and I'm finally delighted to be able to tell you that Thermo Sudoku, our new game, is out on Steam. They have finally released it, so if you have been waiting for that, you can now get hold of it. Big thanks to those of you who've bought the game so far, and obviously a huge thank you to those of you who've written kind reviews of it. Now, what I thought I should do to celebrate is a Thermo Sudoku. And serendipitously, this morning, early on UK time, I had an email from somebody called Mitchell Lee. Now, Mitchell Lee is probably a name familiar to all of you now, because Mitchell Lee created the Miracle Sudoku, which of course is a video that has been going around the world sort of delighting people because it's such an extraordinary puzzle. Starts off with just 2 given digits. Well, this is the follow-up to that puzzle, and when I opened the email and saw this construction, I was like, no, surely not. I mean, the reason is, obviously we've been constructing a lot of Thermo Sudokus for the app, but when you only have thermos that are this short, it's incredibly, it's not much of a restriction. And this grid not only has no long thermometers in it at all, but it has no digits at all in it. So normally you can get round short thermometers by adding digits to the grid. Here there are no given digits at all. So this, I can tell you straight off the bat, is a wondrous construction. And if it wasn't by Mitchell, I would be very sceptical it had a findable solution by a human being. But it is by Mitchell, and therefore we're going to try it. It's not been tested, so you are going to see, me try it, and hopefully I will be able to do it. But I needed a Thermo Sudoku. I wanted one that would be great, and I knew I could rely on Mitchell for that. So fingers crossed. Let me tell you the rules of Thermo Sudoku for anyone not familiar. They are very simple. You can see we have thermometer shapes in the grid. Well, the digit at the bulb end of the thermometer has to be the smallest digit on the thermometer. So let's say that was a 3, say. This square would then have to be higher than a 3. It doesn't have to be a 4, it could be a 6. It could be anything, so long as it's higher than a 3. Then this square has to be higher than a 6. That could be a 7, that could be an 8, 9. This would be a valid setup for this thermometer. And that is all there is to know. Do have a go at this puzzle. Click on the link under the video as usual to play along. And with that, let's get cracking. Now, my only thought as to how to start this is to look at either the 1s or the 9s, because obviously, hopefully it's obvious. Where can a 1 go on a thermometer? Well, it can only go at the bulb end of a thermometer, so it's not actually possible that any of those cells there contain a 1. Or that one for that matter. So the 1 in that box must sit in one of those 2 cells. It's no good in this box though. Down here, it's not great in that box either actually. The 1s are locked into one of 3 positions. Oh, hang on, 1's in the central column. Where can the 1s go? Well, they can't go along a thermometer other than at the bulb end, so they must be in one of those 3 positions. So not quite sure what that means though. Oh, in fact, look, we've got quite a symmetrical arrangement of thermometers with these thermometers. So down here we lock a 1 into the same sorts of positions that we had up there. And this box is well, it's not quite symmetrical with this box because this one has a thermometer sticking out from it, but the effect of the 1's pencil marking is the same. Look, we can eliminate those yellow squares, so the 1's have got to be in one of those 3 cells. But that is not helping me very much. Right, well, let's look at 9's instead. Now, 9's are sort of corollary of the 1's in that they can only go at the other end of a thermometer. They can only be at the very top end of a thermometer, so none of those cells could be a 9. Oh, that's just hopeless, though. No, there's Right, okay, this is tricky. I mean, in this column, the 9 can only go in one of 3 places, because it can only go here, here, or here. Oh, now this, yes, okay, I've got something here. Look at that. Goodness me. Right, so I think what we have to do at the start here is to recognise that there is a very nice pattern on the 9s. Because if we look at the possible positions of the 9s in column 5, I think it's mirrored in column 1. Where can the 9 go? Well, it can only go at the end of a thermometer, so it could go here, it could go here, and it could go there. Now look, these 9 positions are aligning, and the stars are aligning for us, because let's have a look at column 9. Where can the 9s go? There, there, and there. And rather amazingly, straight off the bat, we have a swordfish pattern in this puzzle. That is just startling. Now, some of you may not know what a swordfish is. Don't worry, I'm going to tell you. But this should be helpful, because once we've got a swordfish, what we're going to be able to show once we analyse the logic is that there can't be a 9 in any of those yellow cells there. Now, how do we do that? Well, the critical thing to recognise is that in 3 different columns here, we've locked the 9 into exactly the same 3 rows of the grid. And therefore, however we arrange the 9s within the purple squares, we will always end up with exactly 1 9 in each of these highlighted rows. Okay, so although we got this by identifying the 9s were limited in the columns, the restriction, the value that we get out of the swordfish, is in the rows. So let's look at the possibilities. If this was a 9 in the finished solution, what would that mean? Well, obviously it would mean that you couldn't have a 9 in any of those squares. So the 9s in row 5 and row 9 here would form some subs. They would have to take 2 of these 4 squares. Now obviously the 9s can't repeat in a row, and they can't repeat in a column, so they're going to have to be offset. There's either going to be a 9 here and a 9 here, that's one possibility, or a 9 here and a 9 here. Now if you just study this pattern, you can see that we've got exactly 1 9 in row 1, exactly 1 9 in row 5, exactly 1 9 in row 9. And that's always what happens. However we arrange the 9s, we always end up with this. Let me show you. Let's just do it again. If there's a 9 here, these 2 can't be 9s. We'd have to arrange the 9s in column 5 and column 9 into just the blue squares. We have to make sure they're offset so that they don't go in the same rows. We'd either have this, you can see 1 9 in row 1, 1 9 in row 5, 1 9 in row 9 again, or vice versa. We get exactly the same restriction. And the final thing to note, I can probably undo to just complete the entire set of possibilities. So if the 9 finally was here in the finished solution, we know those 4 squares would have to share 2 9s, and they would have to be offset. And you can see we're going to get the same pattern. So why is this important in this puzzle? Well, I don't know yet, but I do know there's no 9s in the yellow squares anymore. So what can we do with that? We can right, okay, yes, I see. Unbelievable. So we are going to be able to place a 9 in column 2 of the grid, because where can the 9 go now? Well, we know if it's on a thermometer, it must be at the top end, and it can't be in this thermometer, so it's in none of those cells. It can't be here because of the swordfish. It can't be here, that's the bulb end of the thermometer, or there, that's not the top end of the thermometer. So it can only go in that square, and we get a digit finally, 10 minutes in on the dot. Now, what can we do with that digit? Oh, hang on, not this. We don't need to do anything with that digit yet. We need to just notice that, look, we've got symmetrical thermometers here in column 8. So we've got the same thing. Where does the 9 go in column 8? It can't go in any of those squares. So there's only one place it can go. Oh yeah, and now we can use the swordfish because we I went through a lot of trouble to show you that there is exactly one 9 in each of the purple squares, you know, in row 1, row 5 and row 9 of the grid. So where does our swordfish 9 go in row 5 here? Well, it can't go in this square, and it can't go in this square because there's a 9 in the boxes already. So the only position for a 9 in row 5 is that one. That must be a 9. And that means the 1 is at one of the bulb ends of the thermometers in the central box, but that is absolutely useless. So what do we do now? Well, I've not really done anything to the ones here. So do I have to look at 8s now? Sorry about this. Just give me a moment to look at this. I want to look at 8s because obviously the 9s have now restricted the 8s. Oh, good grief, I've got another swordfish, haven't I? That is absolutely unbelievable. This puzzle opens up with a swordfish on 9s into a swordfish on 8s. So if you haven't seen it, just pause the video and see if you can see it, because it's great practice for spotting these things. I should have been a bit quicker, I think, to this, but look, we've got a 9 here. So where can the 8 go in column 5 now? Well, it can go in one of these purple squares. I'm going to change the colour though, because I don't want to... well, that's a bit too light. We'll make them blue. So this is the blue is going to be the swordfish on the 8s. Now, all of a sudden, look, column 2 and column 8 have become restricted as regards the 8, because now I can't put an 8 in this position on this thermometer anymore, because that would imply that has to be a 9, and we know it can't be. So in fact, when it comes to the thermometers in column 2 here, there's only 2 positions that are valid for the 8s, this one and this one. And obviously this square can also be an 8. So there are 3 possible positions for the 8s in column 2. Now, I'm sure you're spotting this now, but look, what's the situation in column 8? That one, and that one. And we've got another swordfish. That's absolutely stunning. It's a stunning setting. So now, actually, I think I'm going to have to get rid of my highlighting of the 9 swordfish, because otherwise I'm going to find it difficult to understand the 8 swordfish. But so now the yellow squares, for exactly the same reasons that we went through earlier, the yellow squares now cannot contain the number 8. And that hopefully will mean something for us. So this, just looking at column 9 here, that can't be an 8, 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 because if that's an 8, that would be a 9, and that would have to be a 10. I think this is the only square that can be an 8 in column 9, and therefore this must be a 9. And that was one of the positions for the 9s on the swordfish, so that's fine. So we get 8, 9 here. means there's a 9 in one of the... Well, that one can't be a 9 because of the swordfish, so there must be a 9 in one of those two cells. Ah, and yeah, we've got... keep forgetting this, but we've got similar thermometers in column 9 to the ones we had in column 1. So where can the 8 go? Yeah, the 8 can't go there. It can't go here. The 8 goes in that position in column 1. That forces a 9 upwards. Wondering if this grid will be another symmetrical grid, but perhaps not, because the thermometers are all... The little thermometers are all in different places. Anyway, I can't think about that. This is complicated enough. Let's carry on trying to spot things. So we've got... Oh, so the 9... Oh! Now hang on. Because where does the 9 go now in this box? It must go here, because of the 9 over there. Which means, doesn't that mean that has to be a 9? I'm losing track of the various swordfish iterations, but I think it does, because in this box, nine can't go here because of that 9. So that feels good. So this is a 9. Now where does a 9 go along here? Well, it must go there. Where does a 9 go up here? It must be in one of those two cells. Okay, so how do we make progress from this point? Sorry if you guys are spotting it. I am not spotting it yet. Eights. I want to use these 8s a bit more, so let's have a look over here maybe. These can't be 8s, can they? Oh, that one can be an 8. No, that can be an 8. So the 8s are on one of... Oh, this can't be an 8 though because of the swordfish. So we do get a little bit of a pencil mark on 8s down here. Now, do we get something similar up there? That can't be an 8 because of the swordfish. That, yes, we do. We get similar pencil marking of 8s up in the top right hand side. Oh, hang on. Oh, hang on, I can do better. I can do better. Where does the 8 go in this row? It can't go here because that would force 9, 10. It can't go here, it's too high on the thermometer. It could go here, and in fact I think it's going to have to. It can't go here. Again, 9, 10. It can't go here. It breaks the thermometer, and it can't go in any of those squares because there's already an 8 in the box. So this is an 8. Therefore, this is an 8, and that's on our swordfish. That makes the 1s more powerful than they were, because now the 1s, where does the 1 go in this box? It can only go in one of those two cells. It can't go partially along the thermometer. So this square... 1, there must be a 1. That can't be a 1. Oh, I forgot, we've got 1 pencil mark there. So actually, we can place a 1 here. This is a 1. That means that's not a 1. The 1 moves up there. Good grief. This is the sort of puzzle that makes my head start to swim. I feel like I'm trying to hold far too many things in my head at the same time. Right, so what on earth do we do now? So we've made really good progress with the 9s and the 8s and the 1s. I haven't looked at 2s for a while, if at all. Okay, that's good actually. Where does 2 go in that box? 2 can't go here because that will force a 1 onto the start of the thermometer. Ditto with this position. So 2 is in none of those cells, and 2 can't be here because if it's there, that thermometer will break in the bulb end. So this is a 1-2 pair. So now we get to do what with that? Those simply cannot be 2. These can't be 2. There must be a 2 in one of those 2 positions. Bringing that back over to this side, that can't be a 2. It's not that good though. That can't be an 8 anymore because we've got the 8 in that row. No, I'm not sure what to do now. Oh, no, I've got something else. Where does 7 go in this row? I don't think it can go anywhere. Well, I think it can go here, but I don't think it can go there. That would force 8, 9. It can't go here. That forces 8, 9. It can't go here. That forces a 9 there. That will clash. It can't go here. That forces a 9 there. That will clash. And it can't go here because that forces 8, 9, and that all clashes. So that is a 7. And you get the same thing with the 6. Look, we can just repeat the logic with the 6. That can't be a 6 because that's going to force an 8 or a 9 into that square. That can't be a 6. It forces an 8 or a 9 into that square. That can be a 6, I think. That can't be because it forces an 8 or a 9 into this square. And that can't because it just immediately breaks. So I think that has to be a 6, which means that's got to be 7, that's got to be 8. That locks a 7 down here. And this thermometer is just we can fill it in because, well, we just can. We've got to put 2, 3, 4, 5 in the column, and we know they must descend along the thermometer. So now, oh yeah, now we get 2s. These 2s, look, they lock a 2 into that square because we can't put a 2 at this end of the thermometer. 2s in this shape. Oh, the 1s can go in the bulb, so we're not going to get... Bother. This is so clever. It's so clever, but it's foxing me. Oh, no, hang on. Yeah, okay, sorry. I could have got this ages ago. But look, we've got 7, 8, 9 here. So where do I put an 8 in this column? I can't put it here, obviously. It's too close. It's the bulb end of a thermometer. I can't put it here. I can't put it here because that will force a 9 into that square where it can't go. So this is an 8. And the thermometer, the way the thermometers line up, where does the 7 go in this column? Again, the 7 must be, it can't go there because it can't have a gap to the 8. So we get the 7 here. Now we can, no we can't, we can pencil 8s there. Starting to get a little bit more traction with the 7s now. And this thermometer is interesting because, actually this thermometer is very interesting because that can't be a very high number. That can't be 7, 8 or 9. This square has got to be, well, if that square is, in fact, I don't think it matters very much what that square is, because if this is 6, for example, it comes into this cell, and this can't be 5, 4 or 3. This simply has to be 2 and 1, no matter what I put in this square. I mean, I could put a 3 in this square. This still has to be 2 or 1. So this square we don't know, but we know it's a low enough digit that these squares always have to be 2 and then 1. That gives us a 1 here. That gives us a 1 there. Ah, now 1, yeah, this is nice. Look, the 1's down here. The 1 could go in the bulb of the thermometer, but it can't go partially along the thermometer, so it has to be in one of these two cells where it aligns with the positions of the 1s in box 9. So where does the 1 go in row 8 of the grid? Well, we know it can't go in those 3 squares. We know it can't go in these 3 squares. So it's got to be in one of those 3 squares, and there's only one candidate that works. That places a 1 on that thermometer. Does that help with the 2s? It might do. 2, 2, that can't be a 2. Hey, it does help. If that's the 2, that would force a 1 below it, and that's impossible. So, oh goodness me, that must be the 2. And does that do... So the 2 must be in one of those 2 cells. So it's not bad, actually. Actually, it's really good. It's really good because these 2s align with these 2s now, the same as the 1s did. So we ask the same question. Where does the 2 go in row 8 of the grid? Now this 2 rules out that square, so the only option is there. And once the 2 is here, we need a number lower than a 2 on the thermometer. I don't believe it. This 1 is going to fix the 1 and the 2 now. That fixes the 2 down there. What a puzzle this is. I mean, this is very, very hard, but absolutely gorgeous. I might have to get rid of, I think I'm going to have to get rid of the highlighting, am I? No, I'll live with it. I'll live with it. Surely I can do more with 2s now. Yes, I can. I can get a 2 in the top. That fixes a 2 here. That can't be a 3 because of the 3 there. So if that's not a 3, the 3 must be next to the 2 on the other thermometer. Those 2 squares have got to be 4 and 5 now. We need... This, it's no use, that square's not good. Oh, that square can't. That square can't be a 3. Oh, this is great. Column 9, we can complete it. Because this square can't be a 3, the 3 must go there. Otherwise, we'd have to put a 2 into the gap, and we can't. So 3 goes here, and once 3 goes here, of course, this is all fixed. We just have to fill it in with the digits that we haven't placed. So that's 4, 5, and 6 now. Now this isn't a 4, so the 4 shifts down there. Those two squares are 5 and 6. This square must be 5 or 6. Must be a 4 in one of those two positions. Not sure how helpful that is. 6. Oh, where does 3 go? Here. Where does 3 go in column 1 now? It can't go on this thermometer anymore because of the 4, 5 here. So it's got to go on this thermometer, and it must go at the bulb end. And oh, this is beautiful, isn't it? Now column 2. This has got a 4, 5 on the thermometer already, so it's got to go here. That places a 3 at the top. My goodness me, this can't be a 4. And if this can't be a 4 because of this 4, the 4 must live on this thermometer, and it must be right there. So that's a 4, that's a 5. So what do I need? I still need to put a 3 in here. That must go here now. So that's 3, that's 7, that's 6. That fixes the 6 and the 5 over there. That fixes the 5 here, look. That fixes a 5 there. That fixes a 5 there. These two squares have got to be 6 and 7. I think I'm going to crack this. I am very, very pleased about that because this is not an easy puzzle. This is a 3. That 6 there sees that square. That's got to be 7. That's got to be 6. These two squares are 4 and 6. Still don't quite know the order of those. And those two squares up there have got to be 4 and 7, which we do know the order of. So that's got to be a 6. 6 in one of those two squares. Those two are 4 and 5. Still can't quite resolve that. This one, with this thermometer, presumably that's going to be important. What do I need? That's not 8 anymore, is it? So what do I need up here? I need a 6. I need a 6. So that's got to be the 6. That's a 9. That's a 9. This becomes a 7, 8 pair. These three squares have got to be 4, 7, and 8. That's got to be a 4, therefore, because... So this is very nice, because that's 7, 8 pair. Well, I can't put an 8 there, because that will make that a 9. So that must be 7. That must be 8. This square's got to be... What's that got to be? 5, I think. That fixes the 5, 4 at the bottom. And the 4, where can the 4 go in the middle? Well, it can't go there because that's got to be a higher number than a 7. In fact, that's got to be 8, that's got to be 4, that's got to be 8, that's got to be 7. The 4, 6 gets resolved, the 6 goes here. And if I haven't made an error, please don't have made an error, that's going to be a 7. What a puzzle. Yes, I did it. My goodness me. Swordfish into swordfish, straight off the bat. Another, and I don't use this word lightly. That is a masterpiece, Mitchell. Absolute masterpiece. Loved it. Let me know in the comments how you got on, and we'll be back later with another edition of Cracking the Cryptic.